All right, Math 1200. Let's get ready for, in a standard 16-week course, week 5, lesson number 2. Of course, we're doing half a year, so everything is going so much quicker. But once it's done, you get a half a year off because of that. All right, what are we going to do today? Heavy review day. Heavy review day. Homework answers, the do it, review, and then quadratic equations. That's what we want to get into. We're really focusing on these quadratic equations. Not just how to solve them, which has been the primary focus of the last 2 days, a little bit of word problems thrown in, and then next week will be just word problems. What we want to be able to do is get you to be able to apply all of our thinking so far, or most all of our thinking, as it relates to real world problems. And quadratics have some wonderful applications to real world problems. Okay, so here is the review of the first homework sheet. I know that these homework sheets have looked a lot alike, and that's the idea of spiraling, to go back and hit these things many times over. By now, I think you should have a comfort level, even though problems are getting a tick harder each time. For example, number 2 has gotten a little bit harder. Number 4 is a word problem, but we've introduced a quadratic now, and so on. But for the most part, there's been enough repetition here that you should be comfortable with most of the questions on the homework, and the other ones in future days I expect comfort with as well. So take a look at this. Of course, you're going to do stop and start. If you have any questions about the homework, please feel free to email me if you don't understand it from the work that I showed. Okay? The big thing that some students will mess up on number 2 here is that, let me go back. Come on, go back. There you go. The big thing on number 2 is some students will forget to do the double distribute first. You don't have to. Definitely don't have to. The order of commutative property says that you can multiply in any order, and it's fine. But I think it's a little easier to do the two binomials first. Okay, so check those answers out a little bit more, and then we'll proceed forward. Okay, let's check out the rest of the homework answers. Okay, remember you can do stop and start. Okay. All right, so as always, if you have any homework issues, hopefully the way I showed the work is able to solve it for you. If for any reason it's not, then you could talk to friends. You can email me. We can set up office hours, anything, as long as you can get these problems right. Today's do it. Go ahead, stop and start. All right. Now, first one. Well, if you notice, this time, unlike the last do it, this time who the 8 is being grouped with is changing. It's a 3, then an 11. That's the associative property of addition. To simplify here, I'm going to distribute the 3, then double distribute the x minus 5 and the x minus 3, then combine like terms. When done, I get 10x squared minus 28x plus 27. Number 3, explain what adding fractions and lining up decimals has in common with adding puppies and kittens. This question is fading off pretty soon. In order to add anything, fractions or puppies or anything on the face of the earth, you have to have a common category, denominators or place value. So when you line up the decimals, you're getting the same place value. When you get common denominators, you're getting the same type of thing, be it ninths or quarters or fifths or 21sts, whatever. Number 4, solve for each. You're going to distribute the 4 first. That'll give you 4n plus 28 equals n minus 8. Then it's opposite side, opposite operation. And you arrive at an answer of negative 12. For letter B, this is the same side, same operation, so it simplifies to 3n minus 3 equals 13, okay? And 4n, minus 3 equals 13. Add the 3 to both sides, divide by 4, and you get n equals 4. Simplify using the laws of exponents. For A, you multiply coefficients, add exponents. So that would be negative 15 x to the 3rd, y to the 11th, z to the 7th. And one of the things I do want you to keep in mind about this is how it translates out to working with scientific notation. In other words, This is really the heart of how I want you to understand math. You're not learning something totally new when you go over and start to learn about the laws of scientific notation. All you're doing is taking the laws of exponents that you have learned already, or vice versa. If you had done scientific notation first, and then you learn the laws of exponents, whichever order your teachers taught this to you in, it is the same exact principle. So if you know one thing, then you know the other thing. And then as far as adding and subtracting scientific notation goes, you know that you have to line up the decimals, because that puts things, anytime we add or subtract anything on the face of the earth, it has to be a like category. So that's why you have to convert back to regular numerals, line them up, and then convert in or return to scientific notation. This is nothing more than an application of something you already know. So by learning these laws of exponents, you're also learning all about how to operate with scientific notation, which, by the way, does have real world applications, because some numbers are just astronomically large with a whole bunch of zeros there, and you're just better off using the laws of exponents. So that's just a really good example of why or how this knowledge transfers. And we spoke about the differences between assimilation and accommodation. You should be assimilating the laws of exponents into how you understand or comprehend or work with scientific notation based on the fundamental principles we've learned so far. You should not be accommodating. Accommodating means you have to build these whole new structures. We don't want to do the cognitive structures. We don't want to do that. We want to learn by saying, oh, this is just like that. And then since you know that, this is learned very easily. Letter B, divide coefficients, subtract exponents. I get 2a, b to the 7th, c to the 4th. And letter C, now you'll notice in A and B, A was a multiplication problem. We multiplied coefficients. B was a division problem. We divided coefficients. We always treat the coefficient with whatever the operation is. So this is negative 2n to the 3rd to the 7th. So I'm going to do negative 2 to the 7th, which is negative 128. And then when I raise a power to a power, I multiply n to the 21st. Also remember, with these laws of exponents, what you do with the powers is based on what it's a repetition of. So for instance, when I multiply exponents, multiplication is, or when I multiply the two terms, multiplication is repeated addition, so I add exponents. Division is repeated subtraction, I subtract exponents. When I raise a power to a power, exponentiation is repeated multiplication, so I multiply. Praxis power. Performance is a function of preparation. Let's have you give this a shot. This is our weekly section of Praxis Power. So look at that. The very first thing they did is give us an equation, which we worked on earlier in the semester. All of these Praxis questions I got from old Praxis exams. 2x plus 4 minus 4x is 12. All I did was distribute. You should have noticed that. Combining like terms, negative 2x plus 4 is 12. Opposite side, opposite operation with the numbers. Negative 2x is 8. Dividing by negative 2, x is negative 4. Ding, ding, ding. Honestly, I would expect every person in the class to get that right. Not only is it not much more than a high school question, but it's a very fundamental question that we reviewed. All right. Give it a shot. Okay, so what do we have here? Let's work with the information. Well, the first thing is you average 425 miles a day for 7 days. So that means you go a total of 2,975 miles. Now, you get 30 miles per gallon, so you divide that distance, 2,975, by 30, and that gives you 99.2. That means you need 99.2 gallons to finish the trip. So it wants to know, how much should you budget? Well, the problem is, at no point in time do they tell you how much each gallon costs. You can figure out the number of gallons. That's pretty easy. But until they tell you how much each gallon costs, you can't figure it out. So how much does a gallon of gas cost is what you need to know. All right. Next up, let's try another one. This time, similar problem, but I actually want you to compute the cost. Okay, so similar idea. 425 miles times 7 days, 425 per day, is 2,975 total miles. If you get 30 miles to the gallon, that's 99.2 gallons. We haven't changed anything so far. But now we know every gallon costs $3.29. So 99.2 times 329 is $326.37. Okay. Next up, go ahead. Now, there are two ways to do greatest common factor questions. One way to do a greatest common factor question, and remember, this is related to the fundamental theorem of arithmetic we discussed the other day. Fundamental theorem of arithmetic says every single positive integer has its own unique prime decomposition. So, one way is to say, well, what's the biggest number that divides into both 77 and 99? And keep in mind, this question is off a praxis exam. So if you said to yourself, why did Professor Lindquist include questions about greatest common factor? Well, the answer to that is some of the members of this class, perhaps all of you, are going to need this for the praxis test. And one of the types of people that we hope take this test is parents who have children, or take this class, parents who have children. And the reason I say that is because the sooner you can get your children to think and understand mathematically, the easier math gets for them. As long as they want to make it a bunch of rules, the more frustrated your children will be with math. So your children will, or your nieces or nephews or whatever, will go over greatest common factor. So knowing about that between the praxis and children helps you out here. What's the biggest number that goes into both 77 and 99? It's 11. So the greatest common factor is 11. That's if you're really good with your multiplication facts. But what if you're not? And my experience is that as time goes on, students are more and more calculator dependent, and they are not. So if you know the fundamental theorem of arithmetic, we can break down 77 and 99. 77 is 7 times 11. Here's the prime decomposition here. 7 and 11 are both prime numbers. We're done. 99 breaks down to 9 times 11, but 9 can be broken down. That's a composite number. 9 breaks down to 3 times 3. So 99 is 3 squared times 11. Now, I look for factors that are on both lists, and the only one I see is 11. So the greatest common factor is 11. Try this one. The greatest common factor of 70 and 98. Not as obvious. Okay, give it a shot. Okay, so 70 breaks down to 7 times 10, and 2 times 5 is 10 breaks down to. So this is 2 times 5 times 7. 98 breaks down to 49 times 2. 2 is prime, so we can leave that. 49 is 7 times 7. So the composite number 49 breaks down to the 2 prime 7 times 7. And 98 is going to be 2 times 7 times 7. And what I want you to notice here is on both lists, there's a 2 and a 7. 2 times 7 is 14. That's your greatest common factor of 14. Of course, you could have looked at it and said, well, what's the biggest number that goes into both 70 and 98? And tried it a bunch and come up with 14. Also want to mention just briefly that there is a quiz that's going to be due on the Friday of this week. So let's make sure that you prepare for that as well. All right, so here's the next question. Solve the equation for x. And I have not taught you anything about how to solve this equation. And it's just a fact that when you take certain tests like praxis, you might not have seen that. Look, this course is not all about preparing for praxis. So we're not going to spend every minute of every day going over all the kind of questions that are on the praxis test. But there's certain strategies that we want to have going into a test. And one of them is on a multiple choice question, how can we know that we get a question involving an equation or an inequality correct every single time? And this is a good question to practice that. So even if you don't know how to solve this, and it's a fairly lengthy algebra problem if you do, then not a problem. Figure out another way, as if they gave it to you on the test. Go ahead. Okay, so the way you can do this is what I like to call test savvy, okay? Test savvy is a smart way to take a test. I coached wrestling for years. I don't know how many of you know much about wrestling, but in wrestling, you wrestle your opponent in this circle in the middle of a mat, okay? But as soon as you go out of bounds, then they blow the whistle, you start again back in the middle. So we used to wrestle this team named Longwood, and our team and Longwood were both outstanding wrestling teams. And Longwood they had Matt Savvy. I call it cheating, but it's not cheating, and it's Matt Savvy. And what they would do is their wrestler, when they were both on the feet, would slowly work their way so that their back was on the edge of the mat, where if they went backwards anymore, they'd be out of bounds. And what that meant is if you shot on them, you would end up out of bounds. A shot trying to take them down, and they'd have to bring you all the way back to the middle. But if they shot on you, they had the whole mat to finish the move. So we would always say, hey, circle your back to the edge of the mat. So we wouldn't let them get away with that. So savvy is understanding. It's smart ways to do things. So I want to talk about test savvy. We haven't covered how to do this question, and no doubt we will not cover every single question on the praxis test. So what do? Well, with an equation, you just check every choice. If you do that, you'll see that 5 checks. Plugging in the 5, the square root of 14 minus 5 is the square root of 9, which is 3, and 5 minus 2 is 3. So 5 definitely checks. That means that I need to check the other responses. For example, the square root of 16 does not equal negative 4. We know 5 works, and then it says 5 or negative 2. So we just have to check negative 2. If that also works, then it's choice B. If it doesn't, then it's choice A. But if I plug in a negative 2, I get this thing that says the square root of 16 is equal to negative 4 when I check that. And I know that on one sense it does, because negative 4 times negative 4 is 16. But in mathematics, we strictly define and say that any square root is always the positive unless denoted otherwise. So when we got the square root of 16 as negative 4, for technical notation purposes, mathematical language purposes, that is not a true statement, even though the square root of 16, negative 4 squared does equal 16. If I want the negative 4 as the answer, I have to put the negative in front of the 16. So the correct answer is choice A. All right. Now, this is a problem we did the other day. Oh, hold it. Why did this happen? Oh, let's go to animations. And oh, I can't do anything about that. Oh, I can't believe that this problem I can't believe that this somehow, see, I make these up based on previous slides, and somehow, some way, this lost the ability to have the work shown after I gave you time to do the question. So please ignore the work in red, do the question, and then we'll go over the work in red. Sorry about that. Okay, so with percents, and we worked on this now twice, if there's a 30% reduction, 70% remains. So 70% of the original price is equal to $773.50. Okay? So here's the equation. 70% of the number has to be $773.50. I divide both sides by 0.7, which is 0.70, same thing. and I get n is equal to, it is not equal to 773.50. Boy, I must have just done this a little too late last night. So let's do this here. Ready? 773.50 divided by 0.7 is, it's $1,105. So let's go back in here and rewrite this as 1105.00 because we're dealing with money. And I'll even put a little dollar sign in there. And let's go play from current slide. All right, so it's $1,105. Okay, I even put the underlines in, and that's coming out later. So somehow the animations got messed up with this slide. Hopefully that's not the case on this one, but I have a sneaky feeling it might be. All right, so at least with this one, we didn't get the answer right away. I underlined the important stuff, which you should be in the habit of doing with word problems. Give it a shot. We did one like this last time. Go ahead. Okay, so one of the great ways to do percent problems is percent over 100 equals is over of or part over whole, which involves proportional reasoning. Hopefully we'll get a chance to cover a little bit of proportional reasoning in this course. I don't know that we will. I have a spot where I'm trying to fit it in. The percent over 100 is part over whole. 35 is the percent, and the whole is 800 people. Cross multiply. 100n is 28,000. Dividing both sides by 100, I get 280. All right, now where are we at? We're at a little factoring help, a little factoring practice, I should say. And perfect practice makes perfect. Anybody who told you practice makes perfect is a liar. If you practice terribly, you're going to perform terribly. If you get the questions wrong on your homework and then you go take your test, you're going to do poorly on your test. But if you do the questions on the homework and then you correct anything you got wrong, and then you go back and do it again and get it right, now you're going to do well on the test. 8 through 11, factor them all. We'll go over the correct answers in a moment after you do stop and start. Go ahead. Okay, so for the first one, if we use the AM technique, you got to multiply out to 20, add up to negative 12. What two numbers multiply out to 20, add up to negative 12? Well, it's negative 2 and negative 10. So that makes our factors x minus 2 and x minus 10. Now, it's also very important to know how to do these factorings on the graphing calculator because sometimes you get some really weird factorings. Numbers that you and I just don't have off the top of our head. And I should also mention that not only do we not have them on the top of our head, which is a bit of an issue, but the other thing to keep in mind is that when we get into some real-world quadratic word problems, there is a whole lot of weird factorings that are coming up. So how do you do this on a calculator? In Y1, you put in the last number divided by X. I like always using parentheses. If you don't for Y1, it's okay. But for Y2, you better use parentheses. So I just get used to it in Y1. Take whatever's in Y1 and just put plus X. In the last column, you look for whatever you add up to, in this case, negative 12. Look at the two previous columns. In either order, it will be negative 2 and negative 10. Okay, let's take a look at the next one. In this problem, you need to multiply out to 14, and you need to add up to 9. So the question is, what numbers multiply out to 14 and add up to 9? Well, the answer to that is 72. 7 and 2, 72, which means your factors are x plus 7 and x plus 2. It's always the same thing on the calculator. For Y1, it's the last number divided by X. For Y2, it's that same exact thing in parentheses, plus X. Number 10, I have to multiply out to negative 30, add up to 7. What two numbers multiply out to negative 30 and add up to 7? 10 and negative 3. So the factors are x plus 10 and x minus 3. If I went into Y1, I would put the last number divided by X, negative 30 divided by X. For Y2, I would put the same exact thing, plus X. All right. For number 11, I have to multiply out to negative 18, add up to 7. Oh, that should say positive 7, not negative 7, which makes us get positive 9 and negative 2. So let me just correct that. File, save, and then we'll go back to the current slide. I'll go through very quickly through these. Now, what two numbers multiply out to negative 18 and add up to positive 7? Positive 9, negative 2, which means your factors are x plus 9 and x minus 2. In the calculator, I would put the last number divided by x, and for y2, the same exact thing in parentheses plus x. You heard me say in parentheses enough. If you notice, for y1, I put every single choice in parentheses. I just put it always in parentheses. And then in y2, I don't forget to do that. Now, what about if you factor trinomials with a lead coefficient other than 1? We did teach this already. Let's see how much you remember. Just try number 8. Go ahead. That's my dog snoring for the record. Okay, so if I said to myself, oh, there's a 2 in front, let's look for greatest common factor. There is none, I can't divide it out. And then if I said, well, what two numbers multiply out to 6 and add up to negative 7, I would be doing this wrong. Because there's a lead coefficient other than 1. AM does not work when there's a lead coefficient other than 1. When that happens, I have to multiply the last number by the lead coefficient. In this case, I have to multiply it by 2. And that gives me x squared minus 7x plus 12, because that 2 that was the lead coefficient gets multiplied by the 6. 6 times 2 is 12. Now I just factor that. I'm going to get x minus 3 times x minus 4. Now the question was changed. We talked about how life would be simple if we could take hard questions and make them easy all the time. You have to remember to come back in and divide by that lead coefficient, the last term. Okay, you balance the multiplication with division. And that would give you x minus 3 divided by 2 and x minus 4 divided by 2. You just take the last terms, the negative 3 and the negative 4, you divide each by 2. Now you simplify if possible. That would give you 4 over 2 is 2. That's x minus 2. That's one of the factors. For the other factor, we do that elementary school trick with like 1 1/2, making it 3 halves, or 1 1/3, making it 4 thirds. And we do that by doing the 2 times the number in front here, which in this case is the variable x. So I get 2x minus 3 times x minus 2. If I check it back, 2x times x is 2x squared. 2x times negative 2 is negative 4x. Negative 3 times x is negative 3x. Negative 4x plus negative 3x is negative 7x. And negative 3 times negative 2 is positive 6. So I got what I started with. This is the most difficult kind of factoring that we're going to do in this course. So now, if you got this down pat, you're in great shape. Let's try numbers 9 and 10. Do them both, and we'll go over the correct answers after stop and start. Okay, so there is no common factor here, so we take and we multiply the last number by the lead coefficient. That gives us 15. So I factor x squared minus x minus 15, and that would be x squared minus 14x minus 15. Let me do a little correction again. It's probably a little bit annoying on your end, but from my end, I'm just not very good at editing stuff. And I miss things because I go quick, and I think my mind goes faster than my fingers or my tongue. So what happens is, I correct it now so that in the future I won't have any issues with that. And that'll also benefit you, because if I am able to find a way to put up the PowerPoint presentations, and that's not a guarantee because the files are so large, and Moodle only accepts files to a certain point. If I'm able to do that, then we will have correct presentations for you. All right, so now I factor x squared minus 14x minus 15, and that gives me x minus 15x plus 1. But you got to remember, you got to balance off that multiplication of the last term by the lead coefficient by dividing by that lead coefficient. So I divide both last numbers only by 3. 15 over 3 is 5, And when I get a fraction left, I take that denominator, multiply it by the term in front, which is just like what you would have done in elementary school when you create a mixed number, which gets rid of fractions. So that's 3x plus 1. Checking it back, x times 3x is 3x squared, x times 1 is 1x, negative 5 times 3x is negative 15x, 1x and negative 15x do make negative 14x, and negative 1 times 1 is negative 5. All right, number 10. Looking for that common factor, it's not there. So I multiply the last term by the lead coefficient. And that gives me x squared minus 18x minus 40, or n, it doesn't matter. Factoring that, I get x minus 20 times x plus 2. But now I have to remember that since I multiplied, I have to divide back to balance it out. To do that, I divide back in by that lead coefficient, which is 5, and I get 20 over 5 and x plus 2 over 5. 20 over 5 is 4. I can't reduce 2/5, so I put that 5 in front there, and I get x minus 4 times 5x plus 2. Checking back, x times 5x is 5x squared, x times 2 is 2x's, negative 4 times 5x is negative 20x. That's negative 18x when you add them up and combine them, which is what you wanted, and negative 8 for the last term. So that's the tough factoring, the tricky factoring, and hopefully you're getting very comfortable with it. My experience is that you will be getting comfortable with it, as I've taught it to many people over the years. Okay, time for a quadratic word problem. Go ahead. Okay. Little real world application here. Let's underline all the important stuff. Well, it's important that we're dealing with a rectangle. I don't really care that it's a swimming pool, but I care that it's a rectangle. It's very important that the length is 3 more than twice the width. And then it wants me to find the dimensions if its area is 65 square feet. Well, anytime I'm starting with a shape, I always like to draw that shape and label the parts so I see what I'm dealing with. In this particular problem, it's a rectangle. I've got the width here because that's the unknown. And then I do know that the length is twice the width plus 3. Remember, more than, less than, last shall be first, first shall be last. Switch that order. That's why I write 2w plus 3. Now, the length times the width, w times 2w plus 3, has to be the area, which is 65. Distribute 2w squared plus 3w is 65. Looking for a common factor, there is none. So now I do the same exact factoring technique that I just did a moment ago, and I take the 2 and multiply it by the end, and I get, first I got to get the 65. I wasn't close enough with my old man reading glasses. First I have to subtract the 65 to get it all on one side and make it equal to 0. Now I multiply by the 2, the lead coefficient. Okay, so I get w squared plus 3w minus 130. That's actually a fairly easy factoring if you don't see it. If you do see it, then you can look on if you don't see it, you can work on your graphing calculator. If you do, you notice 13 and 10 multiply out to 130 and you can get a 3 out of it. So it's w plus 13 and w minus 10. But don't forget, this is the one thing that students will have a tendency to forget with this problem. They get a little ahead of themselves, kind of like I do with lacking of editing at times. I have to divide back in by the 2 that I multiplied by. So w minus 10 over 2 is w minus 5, and putting the 2 in front, I get 2w plus 13. So my factors are 2w plus 13 and w minus 5. And when I multiply them, I get 0. 2w plus 13 times w minus 5 is 0. Okay. Well, when I multiply two terms or numbers or binomials or whatever, and I get 0, this is the multiplying to get 0 property. Maybe it's the guy on the left. One of them has to be 0. Maybe it's the guy on the right. If I do the one on the left, I get the width as negative 13.5. If I do the one on the right, I get the width as 5. I'm running a little bit out of space, so I kind of skipped a step. I verbally said the step. I did not show the step. But they're pretty easy, right? W minus 5 equals 0. Add 5 to both sides. So you get W is 5. I reject that negative answer because you can't have a negative length. So the width is 5 and the length is 2 times the width plus 3. 2 times 5 is 10 plus 3 is 13. And just to check yourself, 5 times 13 is 65. So yes, you know you got the problem right. All right, now let's do a right triangle question, which don't forget, you have the Pythagorean theorem. What does it say? 2 ways to remember it. A squared plus b squared is c squared. I kind of don't like that way very much, because what if they change what a, b, and c are? Then you're in trouble. Or you can do leg squared plus leg squared is hypotenuse squared. That's the way I like. But you do whatever you're comfortable with. Go ahead. Solve for the missing, or solve for the area of the triangle. And to do that, you need to find both legs. Go ahead. Okay. Ready? Leg squared plus leg squared is hypotenuse squared. The first leg is x. The second leg is x plus 2 equals the hypotenuse, which is 10 squared. So I do x squared, but then I got to do x plus 2 squared. And to square something means to multiply it by itself. So that's x plus 2 times x plus 2. And then that'll equal 100, because 10 squared is 100. Let's do a little double distributing here with the x plus 2 times x plus 2. You can see all of these techniques that we taught you all along, all throughout the year. They're all coming back to help with these real world applications. X times x is x squared. X times 2 is 2x. 2 more times x is 2x. 2x and 2x makes 4x. 2 times 2 is 4. Now I can get my x squared and my x squared together, and I can subtract my 100 to get it equal to 0. That gives me 2x squared plus 4x. And if I do 4 and minus 100 to both sides, I get minus 96, and then equals 0. Oh, look at that. I can divide everything by 2. That's sweet. It makes the problem so much easier. X squared plus 2x minus 48 is equal to 0. Factoring that, I get x plus 8 times x minus 6 is 0, right? Two numbers multiply out to negative 48, add up to positive 2. That would be positive 8 and negative 6. If for any instance that's hard, you use the graphing calculator, y1, y2. Okay, maybe it's the guy on the left, maybe it's the guy on the right. If it's the guy on the left, that means x plus 8 is 0. Subtracting 8 from both sides, I get x is negative 8. If it's the guy on the right, x minus 6 is 0. Adding 6 to both sides, x is 6. I feel comfortable, a little bit hesitant, but generally comfortable, not showing you the work for that. I think you can follow it along. I reject the negative 8 because you cannot have a negative length. Seen that before? So x is 6. That makes the length of the legs 6 and 8, right? Because the other one's 6 plus 2. And the area then of the triangle is a half the base times height, which is half of 6 times 8, which is 24 square centimeters. All right. Now, when we do a solve for x question and we give you something simple like x squared equals 9, I could say, oh, square root of x could be positive or negative 3. But what if? What if instead we give you problems like this? The first two are pretty straightforward. We've done a lot like them. Let's answer those first two as we get a little more practice with our quadratic abilities here. Go ahead. Okay, so AM technique, I need two numbers, multiply out to 15, add up to 8. That would be 5 and 3. So x plus 3 times x plus 5 is 0. Maybe it's the guy on the left, maybe it's the guy on the right. This is the step that I have not been writing out for you, but that I think you remember. If not, here's a review of it right now. Subtract 3 from both sides, I get x is negative 3. Subtract 5 from both sides, I get x is negative 5. Now, in this problem, this is not about length, it's not about time, it's not about anything. It's just solve the question. So I don't reject anything. It's only when it applies to a real world problem that I have to worry about rejecting things. And I may or may not. That's based on each individual problem. Okay, for the next one, I need two numbers that multiply out to negative 18, add up to negative 7. Well, that would be negative 9 and positive 2. Maybe it's the guy on the left. Maybe it's the guy on the right. So maybe the x minus 9 is 0. Maybe the x plus 2 is 0. Well, adding 9 to both sides, subtracting 2 from both sides. I get x is 9 and x is negative 2. That's pretty straightforward, and I think you should be pretty good at those. It's just a quick little review. But I do want to juxtapose the first and second questions with the third questions. What do you see is the big difference between the first two and the third? Well, the problem with the third one is it doesn't say equals 0. And for now, for our purposes, okay, we want it to say equals 0 because we're solving by factoring. So my first step is to subtract 12 from both sides. And that gives me x squared minus x minus 12 is 0. Now I can do what I know how to do. So we'll do a little stop and start here. Let's have you solve this quadratic. Okay, two numbers that multiply out to negative 12 and add up to negative 1. That would be, because remember that's negative 1x. That would be a negative 4 and a positive 3, which gives you x plus 3 times x minus 4 is 0. Maybe it's the guy on the left, x plus 3 equals 0. Maybe it's the guy on the right, x minus 4 equals 0. Remember, they're multiplying those two binomials to get a 0. The only way that happens is if one or both of them is 0. They cannot both be non-zero numbers. So subtract 3 from both sides, add 4 to both sides. I get x is negative 3, and I get x is 4. Okay. Now we want you to practice getting everything on one side and solving them through. Go ahead. Do all three. Okay. The point behind the last question, the point behind the last two slides was to really emphasize to you this idea of getting everything on one side so that you can factor it. So in the first one, I got to subtract 8x from both sides. That gives me x squared minus 8x plus 15 equals 0. Notice the standard polynomial order here. The squared term, the x term, the number at the end. Using AM or the calculator, what two numbers multiply out to 15 add up to negative 8? That would be negative 3 and negative 5. Maybe it's the guy on the left. Maybe it's the guy on the right. X minus 3 is 0. X minus 5 is 0. Adding 3 to both sides, adding 5 to both sides, I get x is 3 and x is 5. So once you get to the factor of x minus 3 here, unless there's a lead coefficient, you can kind of do it in your head, which I did on some of the previous slides. Next one, I've got to subtract both 18, or I have to subtract 18 from both sides and add 7x to both sides. In this case, I do two maneuverings. It's not wise to subtract the x squared from both sides to get them all on one side. The reason that's not wise is then you have a negative x squared, which makes the way we factor obsolete. So subtracting the 18 and adding the 7x, I get x squared plus 7x minus 18. Notice how I made sure to write it in standard polynomial order. And when I do that, I always peek in front. The 18 is negative, so the 18 has to stay negative. 7x is positive, 7x has to stay positive. What two numbers multiply out to negative 18? Add up to 7? Well, that would be 9 and negative 2. So I get x plus 9 times x minus 2 is 0. Maybe it's the guy on the left. Maybe it's the guy on the right. Okay. Subtracting 9 from both sides, adding 2 to both sides, I get x equals negative 9, and x is equal to 2. Again, no need to reject anything because it's negative. That's only when we apply our solutions to real-world problems. And then negatives are not the only thing that can be rejected. It's all based on the wording and context of the problem. Last one, subtract 12 from both sides. X squared plus x minus 12 is 0. Two numbers multiply out to negative 12, add up to positive 1. That would be positive 4 and negative 3. So maybe it's the guy on the left, x minus 3 is 0. Maybe it's the guy on the right, x plus 4 is 0. Adding 3 to both sides, subtracting 4 from both sides, I get x is 3 and x is negative 4. Boy, oh boy, have we worked hard on quadratics the last few sessions. And we're really going to apply them to real life word problems next week. The happy recap. Today was mostly review, a chance to assess for yourself any areas where you might need to address, which are very important for next week's project. Or the next, yeah, it is next week's project, I think. If not, it's the end of this week's. Word problems. Underline anything important and use it. Check it off as you go along. Quadratic equations. You want to remember to get everything on one side and factor. Evaluate if the possible answer fits the situation. You might need to reject it. Okay,